department to pass. Thank you. Thanks a lot. Yes, I appreciate it. So we saw two very important clustering methods. One is called hierarchical clustering method. The other one is K-means. Okay. But in the problem with all these things is that no, all the points have to be clustered into some group. That seems to be a common issue, right? All the points, at least hierarchical parallel and distance increase what points gets added to it and so on. But in K-means all points of cluster it's not going to be good because you are going to be adding some outlying points also as part of the cluster, which is not good. You agree with me? So, is there a way to denoise, or what is called, remove observations which don't belong together? So, there must be some definition of what is main outlier, right? That's a period. Maximum distance outlier. So, the algorithm should work, you remember that, in a broad collection of situations. That's what a good algorithm is. So, what we want to define is a collection of points. Points somebody can somebody tell me how many points I have here? Round points. Round points.
9 points.
9 points. 9 points are there. Okay, 9 points are there. Red color, yellow color, blue color. The point is, I want to define some kind of a scanner. Round scanner. Some kind of a scanner. Scanner has, like a, the Buddha Kannadi, rounder. I with some diameter or some radius. I put the condition that now within the circle, I should see minimum of 4 points. This example is like that. That's what we are saying here. So let's say 2 inches of the radius of the magnifying glass, and then I move around all the points, but whenever it is not including 4 points, I will remove that. Okay, I'll set it separately. When they are all including 4 points, I keep them as together as part of the cluster. So 2 conditions: epsilon distance, which is the, let's call it as radius of the magnifying glass, and the minimum point that the magnifying glass should capture. Those 2 parameters are needed to define a cluster. In the what is called dbscan, that is called density-based spatial cluster applications with noise. dbscan. Defined by 2 parameters. What are they?
Epsilon distance.
Epsilon distance, which is the radius of the scanner, which in this case, I can call it a scanner. You can call it as magnifying glass, round stuff. I call it a scanner. So you move around, and then we are also putting a condition there must be 4 points minimum. So I start with anything, any random points here. Let's say A is the story. A and 4 point. This is the circle. Agreed? So I move around. As I move around in the direction of Porunachinga, in the direction of Inge. Does this contain minimum 4 points? Does this contain minimum 4 points? Yes or no? Everybody?
No, sir.
In the circle, do you see what I'm talking? To the left of A, this circle, how points?
And the circle 4 red points.
Minimum 4 actually. 1, 2, 3, 4, 5, including that point 5 is there. Okay, 5 points. How about this one? This one, do I have 4 points? Yes. Of course, including yellow, I have 4 points, right? In this one.
Okay, select the point center.
Yes, yes. That's what the epsilon distance, the magnifier is, right? I go here. Do I have 4 points here? Of course.
Yes, sir.
Do I go here? Do I have 4 points here? Of course.
Yes, sir. 5.
India, do I have 4 points here? Of course.
Yes, sir. Yes, sir.
So if I go here, do I have 4 points here?
No, sir. No, sir.
No, exactly. But I have 1 point at least, additional point. But not 4 points. How about here? Does it have 4 points?
Yes. No.
Yellow. Only 2 points are there, including the right? Only 2 points. Here 2 points are there, including yellow, right?
Yeah.
So when it doesn't contain 4 points, it's called an outline point. Okay, the points that are end points. You can call it as end point also. But if you go here, okay, n, does it contain any points other than n? No. When it doesn't contain any core points, that is called an outlier. If it doesn't contain any core points, the reds are all core points. B and C are end points. N is an outlier. I define 3 terminologies. Core points, end points.
ஒண்ணுமே இல்லனா அவுட்லேயர்ஸ் அந்த B ல வந்து அது பக்கத்துல ஒரு பாயிண்ட் இருக்குறதுனால அது வந்து அவுட்லேயர்ஸ் இல்லன்னு சொல்றீங்களா சார்?
Outlier core points, non-core points define பண்ணு. Core point னா 4 பாயிண்ட் இருக்கணும். அதான் நம்ம கண்டிஷன்.
ஓகே சார்.
இப்போ 3 பாயிண்ட் இருந்தா அது கோர் பாயிண்ட் கிடையாது. 2 பாயிண்ட் இருந்தா அது கோர் பாயிண்ட் கிடையாது. But it is an end point.
End point.
End point.
Okay.
So it is an outlier.
எது 4 பாயிண்ட்ஸ் எல்லாமே அவுட்லையர் அப்படிங்களா?
I'm sorry.
இல்ல எதுல 4 பாயிண்ட்ஸ் இல்லையோ less than 4 பாயிண்ட்ஸ் இருந்துச்சு அப்படினா அது அவுட்லையரா சொல்றீங்களா?
அப்படி சொல்லல. ஏன் அப்படி சொல்லல? Because n is not an end point. Non-core points. It's a non-core point, but it's not an end point. It's an outlier. End points are points which contain, other than itself, 1 point or at least 1 point, but not minimum points. It doesn't contain minimum points.
இதுல எது end points இருக்குதா?
B and C are end points. Right? But n is the outlier. So that doesn't belong to the cluster. All these things belong to the cluster, including endpoints. So if I consider that kind of magnifying glass, will it create clusters for us? That's the kind of question we are asked.
Easy.
It did create a beautiful cluster here, and it identified n as an outlier. Okay. So let's take a look at this screen here. In the magnifying glass that I am constructing will actually identify all these strange things as individual clusters. It's all because of the magnifying glass that I am scanning out. With one condition, 2 conditions, 2 parameters. One is the size of the magnifying glass, and the other one is minimum points it should contain. It will solve these problems. For the first time, we are talking about some unusual collection of clustering law and the law it will do. Do you agree? I'm going to look at this one. Somebody lying, somebody lying down on the ground, right? But this will identify. This is a separate cluster. This whole thing is a separate cluster. This is a separate cluster. This is a separate cluster. These are all outlying points, right? Outliers. This is a separate cluster. This is a separate cluster. This is a separate cluster. This is all happening only because of magnifying glass with 2 parameters: size of the magnifying glass and the number of minimum points you put as a condition that glass should contain. Does it make sense? So again, you don't have to worry about it. Your software will do it, but you have to understand this.
What are these database 1, database 2, database 3? There are shapes. Why is it not a regular shape or x-axis, y-axis? What is this?
The point is the points are together like this. We don't know. For some reason, the points are together like this. We are just giving an example. This is the database 1. In the Mari,
okay.
You remember I had trouble with the k-means.
Right.
Right. இப்படி இருந்தாலும் இது கண்டுபிடிக்க போகுது ப்ராப்ளம் இல்ல. இப்படி இருந்தாலும் இது கண்டுபிடிக்க போகுது ப்ராப்ளம் இல்ல. It identified many outlying points. It's just an example.
Yeah. Okay.
Okay. But there are two parameters. What are they?
One is the minimum number of points. Other one is the epsilon. That is the distance.
Distance or radius of the glass. In this case, it's a glass. Magnifying glass.
Right.
It's not a distance. It is the radius of the magnifying glass. Scanner. You can call it as a scanner. So it's very easy, very straightforward. I have a link here. I want you to go over this one when you have time. Okay. Somebody is explaining dbscan intensity, core points, border points, noise points, all those things I explained to you. You just go through that also. The issue is, again, the epsilons. I want to tell you this very important point. Okay, hold on a second. Yes, take a look at this one. Right? If epsilon is getting smaller, think about it. If epsilon is getting smaller, you are going to find more clusters. Do you agree?
Yes, sir.
Right.
Everybody? Excellent. If the epsilon is getting low, you are going to find more clusters. With the same minimum points. Okay? If minimum points are decreasing with the same epsilon, then the cluster size increases. Minimum points is reduced with the same epsilon, same scanner at some point. But you are expecting not 4 points, you expect only 3 points. Okay. So then, for example, 2 points now, the end points, right? Of course, end points is always part of the cluster, but I'm just telling you. 2 points, now it's going to increase cluster size. Everybody agrees? Think about it, what I said. Okay. Now,
number of clusters, number of clusters if I decrease the number of points, like 4, will it increase the number of
cluster size? Cluster size means what? Number of points in the cluster. That's what cluster size means. Well, if I say minimum is not 4 points, 3 points, cluster size fits that. Cluster size chinnadakma. No. Anybody else? I think extreme case, 1 point da solren. Ellame seethrom or cluster.
Okay.
Cluster size and cluster radius vechi kadiyada, sir?
No. Cluster size is the number of points I'm talking about.
Okay.
Number of clusters is different from cluster size.
Okay.
Right.
Number of clusters is different from cluster size. And what I made the comment here is, I want you to think about this. If epsilon is getting smaller with the same minimum points, there are more clusters. Also, if minimum points are decreasing with the same epsilon, then the cluster size increases. That's the conclusion I said.
Right.
Just logically, I want you to buy into it.
Okay.
If everything is according, no problem. Or Python. Okay. So it will solve very interestingly. This is beautiful, right? The original points are like this. Look at this one. It will beautifully identify all the blues. This is dense points. That's why it's called density based. Dense points. Outlying points. Are you with me?
Okay.
These are all outlying. That's the beauty of this. But I decrease the clusters. If epsilon is getting, I'm sorry, not decrease the cluster. If epsilon is getting smaller with minimum same points, there are more clusters under that example. Because I reduce the size. Reduce the size of the diameter of the scanner. Do you buy that between these two? How I explained it to you? But also, in the shape, I'm going to be the visually, it is giving you all these ideas, but in the multi-dimensional database, it's a different story. There, it's not a scanner of like a magnifying glass scanner. It's a sphere. multi-dimensional sphere. You're taking that sphere catches all those points.
Okay.
Okay. So again, these are all, remember, these are original points. These are red core points of the green down. Right? Core points are green. Red are all border is blue. Border is blue. It's blue. You see? Everybody, there are blues here and there are reds also. Reds are nice. It's amazing. dbscan, how it can identify any shape, it doesn't matter. But it cannot handle varying densities. Take a look at this one. These are original points. Dense, a lot more dense here, a lot more dense here, a lot more dense here. More dense here, of course, more dense. It's a different level of density here. For epsilon is equal to 9.2, some kind of some calculation, some example. Minimum 0.4. Initially, it found out only 3 clusters. Do you see what I'm saying here? Think about it very carefully. It's actually 1, 2, 3, 4, 5, 6 in Solana. 1, 2, 3, 4, 5, 6 in Solana. And I found it as 3. Because of the size of the epsilon.
And it left the dense ones like as it is in the original. They don't disturb.
Differentiate okay, differentiate right? That's my point. Dense or cluster dense and the dense it will consider as part of the whole game because epsilon and minimum 2 parameters determine the clusters.
Right.
So and it is sensitive to parameters epsilon and minimum points. We know that. We already thought about it. Right? It should be sensitive. That's how we built the algorithm. Algorithmic process. That's how we built it. So in this particular example, epsilon is 0.5 and 0.4. There are 2 different categories. We are comparing here. But what I am trying to say is that first thing is that if there are denser clusters inside another cluster, it is not going to differentiate. Okay, unless you change the epsilon and the minimum points, possibly. But it will identify. In this case, for example, K means versus dbscan, right? Because of epsilon, K means when K is equal to 3, it's going to give these 3, right? These 3. K is equal to 3. Minimum points is equal to 4. But the top 2 are considered as outliers because I'm asking minimum 4 points. These are considered as outliers. These will be considered as 3 clusters. Isn't it beautiful example? This is considered as outlier because minimum 4 points only. 3 point we consider as a separate. But it's right now considered as outlier. So only these 3 clusters will be identified. Correct? Again, this is
point outlier.
minimum points 4. Minimum points 4.
Minimum points 4 இருக்கும்போது ஒரு இதுலயும் நம்ம வச்சு பார்க்கும்போது அந்த ஒரே ஒரு பாயிண்ட் நம்ம ஃபர்ஸ்ட் பார்த்தோம்ல n மட்டும் இருக்கும்போது அதுதானே அவுட்லயர்னு சொல்லணும். இல்லனா அது n பாயிண்ட்ங்கற மாதிரி தான் பேசணும்.
I mean, the whole collection is outlier. I don't know whether that's the question you're asking. The whole collection is an outlier for this condition. K is equal to 3 and minimum point. Minimum points 4 and some epsilon, a small epsilon. Minimum points 4, small epsilon. This is outlier and this is outlying group. And these are the 3 that will be identified as 3 clusters. Minimum points 4 in Gellia satisfy. It will be a separate cluster.
அந்த எண்ட் பாயிண்ட் சொல்லக்கூடாதா? ஏன் அவுட்லயர்னு கிளாசிஃபை பண்ணணும்? because அவுட்லயர் ஒரே ஒரு பாயிண்டா இருக்கணும்னு சொன்னவே கேட்கும்.
End points it should be connected to the other, whatever the other what are the cluster is. End point, that's the definition of the end point versus outlier.
Okay. 4
And
points.
here,
Okay. 4 points would connect agla.
ஆமா அது ஆகுது. Yes. அதே போல இங்க ரெண்டு கிளஸ்டர் வேணும்னாக்கா minimum points 3 ன்னு போட்டோம்னா this will beautifully come out as two separate clusters in dbscan. I said that all kinds of shapes it will add to it very nicely, right? But that's not the case with K-mean. Inge or drop on line. I don't know how it will drop. We don't know. Based on various distances, right? It might get mixed up in K-mean. We know that we saw that before. K-means is winner here, for example. Okay, this is epsilon greater than, this distance is epsilon greater than 3. Epsilon. This distance is greater than epsilon. I want two clusters, 2 points randomly selected. This will be one cluster. This will be one cluster. Because epsilon is greater than the distance is greater than epsilon, and minimum points is equal to 3. None of this will, will be a solution for dbscan. Minimum points 3. See, remember 2 parameters are needed for dbscan. சரி சார் இதெல்லாம் கரெக்ட். எனக்கு பெரிய தொந்தரவா இருக்கு. நான் உட்காந்து இதெல்லாம் கால்குலேட் பண்ணுவேன். டிஸ்டன்ஸ் மினிமம் பாயிண்ட்ஸ் எல்லாம் கால்குலேட் பண்ணுவேன். ஸ்கேனர் எடுத்துன்னு போயிட்டு இருக்க போறேன். அதெல்லாம் நடக்காது சார். ஏதாவது வழி இருக்குதா? Python and all. Okay, we can do that. That's not a problem. Sometimes, you can even, your methods might also actually create clusters when there are no clusters. Watch out for that. You are very careful. So that's why you have to try different ideas. This is where, human intelligence matters. Because random data, dbscan created 3 clusters here. Complete linkage created 1, 2, 3 created. K-means created these 3. Am I making sense? You have to be careful. Random data, you can find clusters. Okay. So here is the issue. Every's are determined by the number of clusters, because we didn't say you know a predetermined cluster number. It depends on epsilon and the minimum points. Correct? Epsilon and minimum points. So there is something called a graph that the system will provide you. And before that, I want to tell how to determine the, okay, let me finish this one. So we can order the points to identify clustering structures. So these are the epsilon size. Like the hierarchical clustering, the distance is vertical. Here are the epsilon size. And if you draw a line, how many tips are there before that? Below that is the number of clusters. Correct, Satya? How many tips are there? You fix the epsilon, how many tips are there will tell you how many clusters are there. Prashant, are you able to hear me?
Sir.
So you can run this and, basically that's the idea here. That is called optics. Ordering points to identify clustering structure. Ordering points to identify clustering structure. One second. There are 2 small videos I have. Please, this is 5 minutes, and then another one is, I don't know, maybe another 9 minutes. Okay. Now, the dbscan is beautifully applicable in many applications, and it is a very fast method that is available under the data science applications. It's a new method. Okay. So, for example, here is an example about land use detection. For example, land use detection, because they will be always similar. These are all similarity measures based clustering. Similarity measures based clustering. I'm going to introduce a new similarity measure called cosine similarity later. That's why I bring the word similarity measures based clustering. Similarity measures based clustering, right? So here is the land use, because the similar land use will be clustered together. Do you agree with me? மல்லிப்பூ தோட்டம் போட்டா பக்கத்து ஊர்லாம் மல்லிப்பூ தோட்டம் போடுவோம். கரும்பு தோட்டம் போட்டா கரும்பு பக்கத்து ஊர்ல கரும்பு. You can identify that using dbscan very easily from a satellite picture. You can identify from satellite picture. Does it make sense?
Yes.
Excellent. Potential protein docking sites, you can identify. Okay, because when they dock, the points are very close together. When the proteins dock together, they combine together, come together. Okay. In a GIS, graphical interface system, geographical information system, the influence regions, again similar to the satellite pictures only, dbscan will do a good job. There is also called HDBscan. There is hierarchical dbscan. Okay. Web user profiles, you can use it. Web user profiles. And then, I want to tell you this one again. Optics, I already talked to you about optics. That tells you, look at this one. If I draw here, how many clusters are there? If I draw the line here, how many clusters are there? If I draw the line, let me put it here. So that is available in, that's available as part of the optics shape once again. Suppose I put here, okay? Let me make it thicker. So how many clusters are there? Very straightforward. 1, 2, 3, 4. Everybody agrees with me? And that is given by optics. Remember that. How many clusters numbers are contributing? Similar to hierarchical clustering, where by changing the epsilon, here this is horizontal line is epsilon. I told you epsilon and minimum points defines the clusters. By moving the epsilon, I can find out how many clusters are there. Okay. So, I'm going to give you, it's again, R and Python will do the job for you nowadays. Okay. I'm going to give you, for example, as I am recalling again one more time, if you do, because you fix a certain epsilon, for a certain epsilon minimum points, it will be one, all of them are one clusters with some outlying points, right? Not noise or outlying points. If I reduce the epsilon, then 1, 2, 3, 4, 5, 6 clusters are there. Okay. They are different clusters because it cannot get joined here. By the time it comes here, it's the end of the story. It doesn't touch. Even if it touches, it has to have minimum points. 3 points, 5 points, or whatever. So because of that separation happens here. In the same way here also, the separation happens here. Separation happens here between this and this. Separation happens between this. Okay. So so how many assignments I was talking to you so far? Can you please tell me what those assignments I mentioned? So I'm going to add dbscan example also, okay? dbscan assignment or lab work. If you don't know, then it will be part of lab work. What else I asked you? One of them I already did. Compare between Manhattan distance and the Euclidean distance based clustering for 8 points. Remember that? Okay, we finished that. So 2 more. What are they? I'm going to give you a dbscan assignment. ரொம்ப simple idea, isn't it? It's not a very complicated idea. Problems to solve dbscan, for example, or hierarchical clustering, or even k-means. These are very simple ideas. Will you agree? Undergraduate degree, right? In fact, high school. That's why I always say, I can teach data science to high school students. So very simple ideas, logical ideas, and it has very, enormous power to solve problems. I said land use, protein docking, GIS systems, a lot of things you can solve. Web profiles, you can solve. Are you comfortable what I am saying? Yes. Okay. ஒரு enthusiasm இல்லையே.
சார் திருப்பி படிச்சாதான் சார்
சால்வ் பண்ண போதும். நீங்க ப்ராப்ளத்தை போட்டு சால்வ் பண்ணணும். Assignments should be part of it. Lab work and assignments. Okay. Will be.
Yes, sir.
But I told you what are the other 2 assignments. dbscan I'm going to give 1. I have at least 2 more assignments. What are they? I told you. Can you please recall and tell me? Maybe I should have written that at that time. No, I already clear. So no.
Was about the grayscale.
1%, please. So
Okay, I'll start. First one was the grayscale, that is the picture of flower, take 20 dimensions. 30 dimensions.
Right. Picture of a flower and use SVD to recreate the flower, right? With lower dimension. Recreate the flower, grayscale flower, okay? Grayscale flower at 10, 20, 50, 100 and full dimension. Okay? Full dimension should get back to the whole picture. Okay? That's one. Okay, next please. I will give you the program codes also. I want you to be convinced yourself that it is working. I will give you program codes. Next. Oh, I said you have to read that book, right? That reference, different distances. Oh, I have to introduce you cosine similarity measure. I'll come to that. Anyway, what did he say? I asked you to read that paper. Is that what it is? What is the Euclidean distance?
Euclidean distance and the 10 points
I solved the problem myself. I showed you, right? You remember that?
Yes.
Okay, next.
dbscan. dbscan. Next one. dbscan.
Okay, fine. Using optics, determine the number of dbscan and using optics determine the number of clusters. That's one assignment, okay? Determine the number of clusters. But remember, optics will help you to find out more dense clusters also. So much ரொம்ப dense ஒரு பெரிய clusterல இருந்து வெச்சுங்க. அதையும் கண்டுபிடிக்கணும். Do you agree with me? Because epsilon defines that, right? என்னப்பா பால கட்டுங்களா?
Okay.
Anyway, so far I have only 2 assignment. Sorry, I'll find out. I'll define another assignment. My main point is these are all very powerful methods. You can use it in your job and impress people in solving problems. Okay. I did ask you to go through this distance document. You remember? அதையும் பாத்துங்க. ஒரு 2 சின்ன videos I asked you to go through. Okay. And I'm going to put this one. Throw away your previous PowerPoint deck, PA2 notes. Use this one. Everybody?
Yes, sir.
Okay. Thank you. So now I want to introduce one more measure because we commonly use this measure. Very common to use, in data science. What is called cosine similarity. Okay. What is called cosine similarity. Suppose I have, let's say, 2 vectors, vector 1 and 2. Take a look at my screen, please. Vector 1 and 2. The distance is calculated by x2 minus n. Well, this is the Euclidean distance. Everybody agrees? The Euclidean distance is, I told you, Pythagorean distance, right? This is the triangle. But anyway, the point is, this is the Euclidean distance. But the thing is, there is another distance, another Euclidean distance, the Euclidean measure for similarity. But I want to I want you to look at, what is called the cosine angle between two vectors. And Satya, cosine angle between two vectors now, because if the angle is 0, what happens to H1 and H2?
Same.
They both are the same point. Distance will be
Both are
same.
the same point. If angle is 90 degrees, what does that mean?
One point will be on x-axis, another point will be on y-axis.
They are perpendicular. They are perpendicular. Maximum distance.
They are perpendicular.
Maximum distance.
Okay.
Minimum distance is attained by 0. Maximum distance is attained by 90 degrees. What happens 180 degrees?
180.
180 degrees is same, 0 again. Right? The distance will be, between them will be 0 because it's a cycle, right? So, but the main point is between 0 and 90. The thing is, the length D is a dot product. Length D between A and B. The length D is a measure of distance from A to B is a dot product of A and B. Do you agree with me? You can also write it like this. Okay. Also by trigonometry, cosine theta is equal to distance divided by norm of A, norm of B. That's a cosine distance calculation. So theta is arc cosine of this expression. Arc cosine means inverse cosine. Cos inverse. Okay. Cosine inverse. So my point is, oftentimes we will use cosine theta as a cosine angle between two vectors, two records, as a way of finding how similar they are. Does that make sense? How similar they are means I can use Pearson correlation, which is actually the same as Euclidean cosine distance is same as Pearson correlation, because look at this one. This is the covariance. Okay, this is the covariance, and this is the distance of each one, norm A, norm B, like that. So people use cosine similarity to do all kinds of data science problems. So especially the computer scientists it's same as the Pearson correlation, but they invent these things because they don't have that. Whatever the statisticians have been doing for 150 years. I don't know, for some reason they don't think about those things, but the point is they reinvent this thing. But it is same as Pearson correlation. Doesn't matter. But they will call it as cosine similarity, cosine similarity, cosine similarity. That's what they mean. Everybody with me? So that is another similarity measure. We can use similarity distances. They are connected. The more the similar, distance is reduced. The more the similar, the distance is reduced. The higher the similarity, bigger the similarity, distance is increased. So they are connected. Okay. It's oftentimes, we will switch back and forth sometimes. We'll talk in terms of distance or we'll talk in terms of similarity. These are all very common process. Okay. I just thought I should introduce that. You might hear that later on in the recommendation engine. Okay. So that is about cluster analysis, dimension reduction. Now I want to talk to you about recommendation engine. You want a 5-minute break? Because we are shifting gears. Okay. And we will finish. Idorle etna class number meet panniren, etna hours? Can somebody give me an idea? Huh? How many hours do you meet? Every time when I meet with you, typically 3 hours. I might have missed one class instead of 2 or 3 hours, 2 hours. I think the Deepavali எனக்கு போகும்போது ஒரு 2 hour தான் கொடுத்தேன். Can you please give me
PA2 மட்டுமா?
ஆமாப்பா, PA2 மட்டும்தான். Six 3 hours or one maybe 2 hours, but 6 3 hours 5 or 7. That's okay. 5 6 7. Which one is right?
TA2
TA2 வந்து 12 hours 11 hours வந்து முடிச்சிருக்கோம்.
உங்களோட கிளாஸ் பிளஸ் ஜேகேவோட கிளாஸ் ஒரு 3 hours இருக்கு. அவர் 2 hours இருக்கு.
ஓகே 4 3 அது எப்படி கிடையாது. நான் 4 3 every hour is one விட்டுடுங்க. We'll come back and compensate that one. Are you saying that I have given you only 4 3-hour sessions?
Or TA2 only.
TA2 க்கு இன்னைக்கு 4th session sir.
ஆமா.
So every day we meet, how many hours we spend? 3 above.
ஒரு நாள் 2 hours.
ஒரு நாள் மட்டும் 2 hours.
Okay, so 4 times 3 which is 12. So you are saying 11 hours we have met, right? That's what we have met in 11 hours. So okay, that is fine. We will spend some lab hours also. At least 6 hours we will be spending lab hours. Let's go to the recommendation engine. Are you ready? And I want to see what are the other things we have, the topics. Okay, one moment, please. I don't know. I thought I spent more time. I don't know why I feel that. But anyway, PCA, SVD, factor analysis. Okay, application we have to talk about. Recommendation engine, which I'm going to go over. K-means clustering, this is cover dbscan and optics methods. Introduction to correspondence analysis. Okay, so correspondence analysis and recommendation engine. I want to finish it before we do some, data analysis. Okay, lab hours. All right. So again, recommendation engine. Am I going too fast? I want you to give me some input. Am I going too fast?
Yes, sir. There are topics that are drier and all. Maximum. Probably we will revisit these topics during lab hours. We are fine with it.
Okay. Everybody feels the same?
Yes, sir.
Okay. That's fine.
Yes, sir.
So, Napa? Solunga.
Yes, sir. Same.
Oh, okay.
Sometime we need to rehearse on it and then.
Yeah, and I want you to spend time. Now, at least 10 hours spend. At least it should be twice that. Reading, going through this. But I think generally there is no confusion when I explain these things, right? So I hope you can go faster. Okay, taking a look at all these things. I just look at it. Okay, so a lot of good stuff here in this, 200 slides. Right? How many slides? 230 slides. A lot of good stuff. Some of them probably as repetitions. Okay, let me go to recommendation. Okay. All right. This is another way of clustering. Okay, grouping together. So this comes under, because of that, it comes under unsupervised solution. Okay, because of it comes under unsupervised. So here, take a look at this one. First, we'll look at it as individuals and products, and then we'll go to movie example. individual product. There are 8 individuals and there are 6 products. Can you read this one? Is it you are able to read this?
Yes, sir.
Okay. So first individual has has evaluated and given input about product, information that the product one is, or it can be even movie. That's fine too. Let's see. 4 scored. 4. The third person also scored it as 4. Fourth person scored it as 2. Fifth person scored it as 1. Sixth person scored it as 2. 3 people did not score. Okay. Regarding the second movie, I said second movie or product. The movie, I'm going to show movie example later. The first person scored the movie U2 as 3. 1 to 5, score is 1 to 5, 3. Second person did not score it. Didn't see it, didn't score it. Third person did not score it, didn't see it, did not score it. Fourth person did not see, did not score it. Fifth person gave a score of 2. Sixth person gave a score of 2. Seventh person gave a score of no, he didn't give the score. Eighth person didn't give the score, didn't see it, didn't give the score. Can you interpret everything now? How about this? U5. First person gave for the movie, U5 movie, whatever that movie is, has scored 1. Second person gave score 1. Third person did not give any score. None of them gave any score except the 8th person, which also turned out to be 1. So you understand this data, right? Everybody? Now I got a new movie. Okay. Let me see whether I can. Oh, I don't know what it is. Whether I can open this Excel sheet. So a new movie is selected. The first person didn't see it, didn't give a score. Second person didn't see it, didn't give a score. Third person saw that movie, gave score of 3. Fourth person saw that movie, gave score 3. Fifth person did not see, did not give a score. Sixth person gave a score of 1. Seventh person did not see, did not give the score. Eighth person gave a score of 5. The question is, whom should I recommend this movie to? Whom should I recommend this movie? Is the question clear to you? The setup clear to you? படிக்க முடியுதா இது? I'll make it bigger maybe.
Can you put the file, sir?
I'm sorry, what is that?
Can you just put the file in Canvas? Probably we can also pull it over.
Oh, I see. It is there already in your existing PA2 notes. No, I'm sorry. No, not the PA2 notes. This is your right recommendation engine. Okay, let me put this. One moment. As announcements, okay?
Yes.
I will add later on the codes. Right now, I'm just doing this, okay?
Okay.
Just giving you this recommendation engine. Here it is. Okay. I may have to do some. I don't know. Maybe okay, or I will have to load it into Google Drive and give you this in future, because the more I load it, then I know they're going to catch. This Canvas people will catch up with me and ask me that I'm spending a lot of space, pay for this. I don't know what, right? So, but anyway, I sent you this one. Check it out, please.
Yeah, it is there.
You got it?
Yes, sir.
Excellent. So go to this slide 2. We are talking about slide 2. Okay. So the question is really how similar the user, to other user. This user, a particular user, how similar he is. That's what we are trying to find out to other people. The most similar person's interest, we will put that score there. Are you with me? If it is only one person I want to select, the most similar user, whoever looks like that, I will post his interest. That most similar individual. If I have one, if I have two people, I want to take two people most similar. What did I do? I will take an average of those two people's scorings.
Repeat பண்றீங்களா? அது question புரியல சார்.
என்னப்பா?
Question புரியல எனக்கு.
What I'm saying is, I got one. The seventh person comes in. Seventh person comes. Use select means that's what user select. Okay. Seventh person comes in. I have 6 people data. Seventh person comes in. What should I, the seventh person, what are the scores I should put here in these question places? That's the question I'm answering. I'm saying whoever is most closest to this guy, I will put all his scores if it is only one person. If I say most similar only, most similar two people, I will take an average of those two people and put it. Got it?
The question mark fields I'm trying to fill.
Yes, that's what we are trying to fill. Okay. And what I am saying is I am going to use the most similar person to this guy's scores. Very simple. It makes sense, right?
Right.
Cosine similarity use பண்ணனா என்ன சொல்றது? ரெண்டு வெக்டர் சேம் வெச்சுங்க multi-dimensional space. I'm talking about 8-dimensional space of the movies. Items are I. I'm sorry. Movies are actually movies are I. User are rows. Maybe I confused you before. Okay. Items means movies. That is down columns. U is user. What I'm saying is, if two vectors in the product space, in this case movie space, two vectors are same for two people, it means they are similar interest. That's all I'm saying. They are similar. I call it as interest only because the interest is specified by scores, which are the multidimensional point. Everybody with me? Any questions? Is the setup clear to you now, Satya? Excellent. So now என்ன பண்ணனும் இப்போ similarity measure calculate பண்ணனும். Similarity measure is what? This is the cosine similarity. Do you agree with me? I have no கொஞ்சம் சின்னதா இருக்கு இல்லையா? I will try to make it bigger. Now you can see this is the cosine similarity we talked about. Everybody agrees with me?
Right.
This one. பெருசா இருக்கேன் இப்போ வரலையா தெரியலையா? You can read this. This is a cosine similarity we talked about, which is same as Pearson correlate. You remember because it's the covariance, right? மேல இருக்கிற covariance கீழ இருக்கிறதுலாம் variance is a standard deviation. So I'm going to calculate cosine similarity. Okay, and so let me open this. I open pantana. So what I am going to do is the user selected as scores for item 3, 4, 6 doesn't have scores for 1, 2, 5, and 7. We don't have scores for 1, 5, 7. 1, 2, 5, 7. We don't have score. We have scores for 3, 4, 6, and also 8. Okay.
Yeah.
We want to see what are the items we can recommend. That's the question we said. What are the items we can recommend to this guy? That's the problem. We are trying to do that. So we want to see who is the closest. Again, I'm repeating, who on an average could be good representative user. If I use multiple people, it's an average. If I use only one, most closest, no, only one person.
Only one.
We calculate similarity of individuals on the basis of top 3. In this case, I'm using 3 individuals, top 3 people. I'm going to show the calculation for top 3 similar people. Okay.
Oh.
So we calculate similarity of individual on the basis of top 3 new recommendations for I1, I2, I7. I1, I2, I7, I1, I2, I5, I7. Actually, I5 should also be included here. I1, I2, I5. Top 3 recommendation. Okay, I1, I2, I5, I7 normal actual, you know. But we want to take only 3 people who are most similar to him. So far, we are good, right? So I calculated similarity measure. Inga parunga, average எடுத்துறோம் தெரியுதா? B3, B5, B6 for I1, I2, I3, I4, I5, I6, I7, I8. I'm taking the similarity measure for I have to do the okay. So this is the U1. You select, you know, whatever the new candidate is. Please listen to me very carefully because it's a little bit confusing. I don't know. You select is this guy. I take the cosine similarity with U1, U2, U3, U4, U5, U6. Okay, only 6 people are there. Correct? That is this one. Some product. You see this one? This is the covariance. Some product, the numerator. Do you see? Can you read this one? Which is the top. Bottom is square root of sum of squares of these items. Everybody agrees that this is the cosine similarity value? Everybody agrees. Do you agree that these are all the cosine similarity values? Agree, yes or no? Please see the screen highlighted. These are the cosine similarity values. Correct, Satya? There must be how many of them actually there? Only 6, because only 6 people data are there. And I want to know you selected you is, you know, similarity, how similar he is for each one of them. First one is 0.5. Every calculate panna. In the formula is, you know, some product. This is some product, right? Numerator is some product. That's what here you see. Do you see this one, some product? Yes, everybody? Do you see some product? For the first value I'm talking about, 0.5, some product of B3. B3 to I3. Some product, B3 to I3 and B10 to I10. Divided by square root of sum of squares of A's and sum of squares of B's. Right? Square root of again sum of squares of B.
ஒரு சிலருக்கு கொஞ்சம் ஸ்கோர் கொடுத்துதான் கொடுக்காததுக்கு நம்ம ஸ்கோர் போடுறோம்.
Similarity தான் கேட்கிறோம். Who is similar to you select? Similar people to you select. Top 3. Because that is my condition. 3 பேரோட average போடலாம். Top 3 people order similarity measures. First I calculate first guy is 0.5 similarity. Second guy is 0 similarity. Don't use that, obviously, right? Third guy is as 0.5 similarity. Everybody with me so far? Fourth guy has 0.6 similarity. Fifth guy has 0.4 similarity. Sixth has 0 similarity. Forget about U6 and U2. What are the top 3 here?
U1, U3, U4.
Correct. Those are the top 3 people. அவங்களோட average scores நான் post பண்ண போறேன். Am I making sense to you?
சார், அந்த சிமிலாரிட்டி வேல்யூ நம்ம கண்டுபிடிக்கிறோம்ல, அது வந்து cos theta ஃபார்முலாவா?
No, I call it as cosine similarity. It's called cosine similarity. Yes, you are right. You know, the dot product divided by the square root of, you know, each of the vectors. Norm A, norm B.
Okay. இப்போ எனக்கு வேல்யூ அந்த காஸ் தீட்டாக்கான வேல்யூ கம்மியா இருந்தா தானே சிமிலாரிட்டி அதிகமா இருக்குன்னு அர்த்தம். அப்பதானே ஒன்னா இருக்காங்கன்னு அர்த்தம். இல்ல அதிகமாக தனித்தனியா இருக்காங்கன்னு அர்த்தம். நீங்க ஃபர்ஸ்ட் பேசும்போது கேட்டீங்கல்ல, 0வா இருந்துச்சு சிமிலர், 90 டிகிரி வந்தா தனித்தனி.
Yes, hold on a second. Did I say anything wrong here? Let me see. Maybe I would have messed it up. When do you say 2 vectors are same? where the cosine value is 0. That we understand. The angle is 0.
Theta.
Cosine value eவ்வளோ? 0.
Okay,
Cosine of 0 is what?
Cos 0 is 1.
That was probably I didn't say it correctly there. Cosine of 0 is not 0. Cosine of 0 is 1.
Yeah, okay, sir.
So that's why Pearson correlation, two vector on the Pearson correlation will be 1 also.
Okay. Cos
Thank
9.
you. Yeah. So these are the three people, U1, U3, U4 are the three most similar people. You want to consider their scores and put average there. That's as simple as that. Okay. So adanoda moonu score edthana I get for I1 U1 is U1. Okay. U3 is 3. U4 is 4. So idanoda average na rendu value average is 3.5. That is what this one is. Everybody? That is what this one is, right? So I wanted to color it. I can't color it. I don't know. Format cell, let me see. Number 11, border fill. You see this one, 3.5 is just, because there are only two values there, the average is 3. Everybody agrees with me? Correct me, Satya? Prashant? 3.5, I want to take, this is the rule. I just said, 3 people would average, top 3 people would average. That is my rule. I could have said, only one person. I could have said 3 people, 4 people, 5 people, anything. In an actual application, there will be 100,000 people. Netflix is, what? 25 million people. And movies are 100,000, 120,000, something like that. Right? So I can put some, it may look like, subjective, but that's okay. The more the number of averages you use, it's better in general. By central limit theorem. Okay? Everybody? So what I'm saying is this 3.5 is coming from these 3 users. One user, U1, U3, U4. You agree with that? Why do I select U1, U3, U4? Because they have the maximum similarity with the new user. Maximum similarity with the new user. Do you buy that so far? Satya, correct me? Okay. That's how I got this. But then there are only 2 values, so I got 3.5 average. Let's go to the next one, I2. I2 la U1 value 4, U3 kadiyadu, U4 kadiyadu. So what is the average value there? Just 4. Agreed? Everybody? For I2, I'm saying the average value is 4. Everybody buys that or not? There is only one value. So I just put that as average. If it's 2 values, I divide by 2. 2 values, sum them, divided by 2. If I have all the 3 values, let's see whether is there any 3 values available. I'm not sure. And then I go to because next one is missing is this one. That is I5. I5 can now the U1.
4 by
U3 இருக்கணும், U4 இருக்கணும். இது 3 வேல்யூ கேட்டது சேர்த்து எவ்வளவு இருந்தது? 4. 4 divided by 3 is how much? 5 is 4 divided by 3 is 1.3. So it's rounded to 1. Agreed? Everybody agrees? Correct, Satya? Finally, 7, I7. Right? I7 la vandu 1 illa inga 1 3 4 irukku oru value irukku 2. So I put that as 2. Now you got, everybody got it? How I got the answers? One, 2, 3. Yeah. And then I just want this one. 3, 1, 3. This one yellow. 1, 2, 1, 2, 3 கிடையாது. 3 போடணும் இல்லை. நமக்கு தேவையானது வந்து 1, 2, 5 and 7 தான். இது போடக்கூடாது. No fill. And then 5 is this. 7. Everybody get it? Everybody understand what I'm doing here?
இந்த ஆவரேஜ் எடுக்கிறது புரியுது சார். பட் அந்த சிமிலாரிட்டி நம்ம கண்டுபிடிக்கிறோம்ல ஃபர்ஸ்ட் இந்த யூ பாயிண்ட். இப்ப அதுல வந்து நான் யூ செலக்டுக்கு அந்த 6 யூசர்ஸோட யாரு சிமிலர்னு நான் பாக்குறேன். பட் நான் பார்க்கும்போது யூ செலக்ட் வந்து எனக்கு 4 ஐட்டம்க்கு தான் ஸ்கோர் கொடுத்திருக்கு. 1, 2க்கு நான் கொடுக்கல. நான் அந்த சிமிலாரிட்டி வந்து கொடுத்திருக்கிறதுக்கு மட்டும்தான் பார்க்க முடியும்ல.
Of course, yes, of course. The calculation, some product, those things, those we don't have data, it's not going to contribute. You are right. This is based on the. So you select on the new user. That's confusing. Okay. New user. New user. Okay. So you are right. It's not going to contribute. So this vector cross product with each of these vectors in the numerator is not going to have values for those which have question mark. Either one of them on both sides. Okay.
Okay. So இப்ப இந்த ஃபார்முலால சிமிலாரிட்டி கண்டுபிடிக்கும் போது I equal to 1 to n எனக்கு 8 ஐட்டம் இருக்கு. 8 ஐட்டம்க்கும் எனக்கு ஒண்ணா பார்ப்போம் எப்படி இருக்குன்னு. இப்ப எனக்கு ஆக்சுவலா அந்த 5 வேல்யூஸ் மட்டும் தான் வரும். 4.
Wherever the question mark is there, I need to fill up. Rest of them, I'm going to keep the other values as it is. So I have 4 question marks, so I'm filling in 4 question marks. The yellow are maybe it's confusing. Okay, 4 yellows are there, right? Those are the only things I need to fix. Agreed? Everybody? So, and then you asked the question, I said, we want to use the average of 3 people, or top similar people or the average score 4. That is a decision I made for this example. So why not 4? Of course, you can use 4. The more, the better, because by central limit theorem, you'll be converging to the average. But in this toy example, I'm using 3 people. So this is called user-based. You can also do item-based. Given a new item, who is likely to score what? But that's a column data. Everybody with me? I can do user-based. I can do item-based. Correct, Mularna? Satya.
ஐடென்டிஃபை பண்ணிருக்கிறது இந்த யூசர் வந்து ஒவ்வொரு ஐட்டம்க்கும் எவ்வளவு ஸ்கோர் கொடுப்பான்.
Yes, likely to score, exactly. Likely to score. அது எப்படி பண்றோம்? The clustering தான் இதுவும் similar people இருக்காங்களோ. Similarity is same as distance, remember. Okay. The lower the distance, the higher the similarity, right? So what we are saying is it's the method used for recommending some people for a new person, what to recommend, or for a new product, whom to recommend. Yana Satya Sunna. Okay. Karana. I was saying, like this is user-based recommendation. I can also do item-based recommendation. That you buy it.
Icon-based.
Item-based. Column. Right now, row which one?
Okay.
Everybody? And this is a 6 rows and 8 columns matrix of data. I can also use hybrid version, user-based and item-based recommendation using SVD. Am I making sense? இதுக்கு நான் SVD-ல எது first top 3 dimensions only யூஸ் பண்ண போறேன். பண்ணலாமா? ஐடியா இருக்கு, ஒரு ஐடியா இருக்குல்ல, அந்த மாதிரி பண்ணலாம்னு ஒரு ஐடியா இருக்கு. Will you buy it? We can do that too. But the point is, these are the foundation ideas. So let's go and do the movie recommendation. How about that? Are you ready? Okay, so let me go to the R program. And it'll call open a file. Let's see. It should be in my PDF too. So we have movies, ratings, links, and tags. 4 files are there. Movies, ratings, links, and tags. Okay, movies and ratings. Links only, it gives you some information to another database you can connect. And then tags refers to certain keywords, right? Every movie has some tags, like, an essay will have some tags, right? And the movie has some tags, which are keywords that defines the movie. Okay. So I'm going to read the data, movie data, rating data, links data, and tags data. Everybody understands? I have it somewhere here. Users, USSS, download, YAML, latest small data set, movies.csv, and my all file in my system. I read. Can I read that? Yeah. Let's do that. So run. Run the current line or selection. Control enter, also called control enter. Okay, so it has already read. I have no errors here. So what do we have? Let's see the movie one. Or sorry. I should be typing here. Movies. Actually, I can view movies, right? That's better, maybe. See here at the movies. Do you see this one? Can you read? Can you read? I don't know whether it's too small. Type movie ID, title, and genre. Movie ID, title, and genre. Toy Story, 1995. Genre is adventure, animation, children, comedy, and fantasy. Movie 2 is Jumanji. I don't know whether you have seen Jumanji. I have seen that. It's a fun movie. It's a kids movie. I think kids movie. Children, adventure, fantasy movie. Okay. Grumpier Old Man. I haven't seen it, but it's a comedy and romance. Romance means usually not a crime movie. That's all. Not necessarily. It can be more, other things also, other type of romance also. But no, I'm sorry. Comedy means comedy. That means no crying about. Okay. Romance is, romance. Whatever we know as ordinarily as romance. Waiting to Exhale. Father of the Bride 2. I think Father of the Bride 1 part. I have seen this heat when I came to this country first time. It says 1995. I'm sorry. Yeah, I came to 1992. Oh, they showed me as a pre-release when I was in Southern Methodist University. Pre-release in 1993. 1 or 2 years back, they showed me. I saw that. I don't even remember what the movie is. American President. Okay. So that's what this is about, movies information. Now let's see view ratings. So user ID 7 has seen the movie 1 and given a rating 3.0. எப்போ கொடுத்தாங்கன்றது time stamp. So for user ID 7 has seen the movie 1, movie ID Toy Story is seen by how many people? Maybe I should put a table. Table, ratings, dollar, movie ID. movie ID. I don't want all the things. I just need only movie ID is equal to 1. No. Let me see movie ID. It's going to give a long table, but let's see. Wow. No. What is that? Table. What is going on? Cross tab. Wait a minute. I have to see the table. Just a moment, please.
Sir, that movie ID D is small, right?
D is small. Okay. Right. That's the reason why you think I could not get it. Maybe.
Oh, can you check it?
Yeah. You're right. Movie ID. Right. I also. I don't know. I is uppercase, lowercase. I is. Let's try both. I don't know. Okay. Yes. Here it is. So, first movie is has how many scores it has? It has 247 scores. That's what it means. Everybody? Jumanji has 207 scores. 107 people have given information. Thank you very much. That one. I is uppercase, D is lowercase. So you understand this, what how I am interpreting movies and then their scorings and ratings. Okay. I also have the link. Let's go and see what does link mean. Okay. View uppercase. I think it's uppercase. Right? View. Why do I do this? I can call in. View links. So it's basically it is the movie ID 1 is mapped to the IMDb database, 114,709. Tomato database, no, another database that is 862. Just it's another link. I don't care about that. Okay. And then I have what are the other things I have? 4 tables I have, right?
Tags.
Oh, tags, right? So view tags. You see, movie 1 has a tag called Pixar. That's that's not surprising, right? It's a Pixar movie, Toy Story. Movie 5 is Steve Martin. That's the Father of the Bride. I think I remember, right? Father of the Bride. Steve Martin was acting in that one. So like that, these are all key tags. Sometimes it could be multiple tags. Look at this one: imaginary world, character, story, philosophical, space, epic, science fiction, hero's journey, and so on. Multiple tags are also possible. Okay. Now, let me go back to the recommendation engine. So, I want to make it as strings. All these things because they are strings. Let me run that one. There are 1,296 observations with 4 variables: user ID, movie ID, tag. For the tags, like that, not strings, structure. I'm sorry, structure. Structure means it gives you that information, data information. So the ratings is data frame 100,004 observations of the ratings. User ID is integer, movie ID is integer, ratings is number, timestamps are there. And movies have 9,125 movies. Movie IDs are 1, 2, 3, 4 like that. Title is a factor, okay, because it's a string. It should not be factor. It should be read as a string. So I'm going to reread this, in the new data set in genre. I'm going to string as factors, false or true, depending upon what I need. Okay, genre is factor. It's considered as 902 level because it's a factor. Okay, so to obtain the movie features matrix, the 5 summary. So I have 5 separated genres in each one of the movies. Do you recall that one? I get 6 or 7 genre information for Toy Story. Okay. So I'm going to separate them out and write it, into a data matrix 0, 1, 0, 1. If that particular, there are 15, 16 genres there. And if whatever the genre that happens in a particular movie, that will column will have 1 value. Otherwise, it will have 0. That's the kind of data I want to create. Why? Because that, unless I convert that genre information, because I can use the genre as a covariant to define the the similarity matrices. Okay, because there are certain types of genre will have certain scores from certain types of people versus other genre. So we want to control that information. So genre is I'm reading a new data set as data frame from movies, specifically only genre information. So let's run that one. And if you look at view genre, what do you expect? It will be a whatever 15 column or 8 column. What is the maximum number of genre information should be there as a number of columns? Now let's see. Not right now. Until I split, it won't be. It will just write everything as one genre, but then we are going to split the pipe by the pipes, the pipe symbol. Everybody with me? But when I split it by the pipe symbol, here it is adventure is there, comedy is there, fantasy is there, but no romance is here. So all these things, the common element will be put together in one line. Okay, that's our interest. So let me stop here. Shall we stop and then do tomorrow? Finish this one and do maybe another assignment also. So the point is, I got to calculate similarity measures for each of the user evaluation vector. Okay, whoever is similar to them, top 10 people who are similar to him, take an average and put the score. That's what I'm going to do. Same thing what we did, but using R for 100,000 movies, 100,000 evaluations, 2,000 movies approximately. Does it make sense?
Yes, sir.
Sounds good. Tomorrow continue.
Yes, sir.
Sure.
Okay,
Thank
sir.
you. Thank you very
Sir,
much.
can you send this recorded session?
Yeah,
Right.
remember that I have only recorded half of it. I'm sorry.
Yeah, okay, sir.
But next time. So I will. When I stop, it will stop. Okay. Anything else?
நம்ம இப்ப இதுல வந்து எந்த யூசர் வந்து எந்த ஜானருக்கு எவ்வளவு ரேட்டிங் கொடுத்திருக்கான்னு பார்க்க போறோம்.
We are going to see similar before. Which user is more similar to the top 10 users in terms of ratings? But we will also bring in the genre information into the ratings. Okay.
இந்த ஜானருக்கு எவ்வளவு ரேட்டிங் கொடுப்பாங்க அப்படின்னு பார்க்க
Yes.
போறோம்.
Yes.
ஐட்டம்ஸ்க்கு இங்க ஜானர் மாதிரி.
It is the same information what we did. So forget about genre. Genre-வே இல்லைன்னு வச்சுங்க. ஏன்னா the genre based scoring is happening there. Okay. What I like, because certain types of genre I like. So I have to bring in the genre information also here in order to get a better user similarity measures. User similarity measures. Okay, we'll see.
Okay.
We'll see this tomorrow. Any other question? We will go through this tomorrow and then solve this problem, and that's all you will do for your any other big problem. So you may have in a store, you may have let's say 1,000 products, and you need to, when somebody enters into the store, you want to give a recommendation. Hey, you know what, you may like this. அது எப்படி இன்டெலிஜென்ட்டா சொல்றது, அதுதான் இது. For example, if you write an app for a retail store, the retail store has 8,000 products, let's say. Some of them may be there, some of them may not be there. Some of them may be having a score from each one of us. Some of them may not have any score. Whatever, right? 8,000 products. So when the person comes in, he needs to be recommended. Oh, hey, you know what? We got a new load of new inventory of this product for you. Because when I enter into a store here, for example, Whole Food in ஒரு கடை இருக்குது. Okay, அது உள்ள போனாக்கா I already have stored their Wi-Fi, so it knows me. That the moment I come in, it knows me that I am coming in. That I voluntarily gave that information because I wanted a Wi-Fi. அங்க உட்கார்ந்து வேலை பண்ணணும், நல்லா இருக்கும் அந்த store. So I go there and do this purpose, but then they capture my Wi-Fi ID, my Mac ID, and then they know the moment I enter, they'll say, "Hey, Netra, come in, welcome. I got a special coupon for you, and also we have fresh tomatoes just landed an hour back. Oh, tomato in a veno, so I will go and buy it. And there are different tomatoes are there. They will recommend specific tomato which I bought in the previously and which I rank higher, right? Makes sense, very simple. But it's a very automated, beautifully automated app that you can write today. Of course, பண்ண சொல்வீங்க என்ன சார் இதெல்லாம் வந்து மேத்தமேட்டிக்ஸ் லேப் ஒர்க் இது எப்படி how to do the work, how to develop the algorithm தான் சொல்றேன் எப்படி வந்து API எழுதுறது for separate course. The point is right now we are making you to be a data scientist, and then we have to make you as a technologist. Then you will write an app. Apple better, yeah, because it's automated. Then other companies will pluck you away from your place. Any other question? No questions. Okay, thank you very much, everyone.
Thank you.
See you tomorrow.
Thank you.
See you tomorrow. Bye. 4 hours 14 hours முடிஞ்சிரும். கரெக்ட்டா?
Yes, sir.
அதுக்கப்புறம் ஒரு 6 hours நம்ம லேப் பண்ணலாம். Maybe JK will take, I don't know, okay, whatever. I might also take, I might review whatever the work you do, whatever. Okay. Thanks a lot. Bye-bye. Have a great
Bye.
day. I have to switch off here. That will give me the end meeting all. That will give me the recorded version. And I'll post it today.